right, this is Honors Algebra 2 Pre-Calculus, and we're going to be doing example 6 in 9.4 today of pre-calculus, which is mathematical induction. So this example is actually in the textbook on page 650. So we're going to find an explicit formula for the sum provided here, and then we're going to use induction to prove our own formula. So in order to find this formula, we're going to have to start by basically looking for some patterns. So what I'm going to do in order to find this formula, so there's essentially two jobs here, right? Part A, find the formula for the sum, and part B, use induction to show that you're correct. So let's start with part A, right? Let's start with finding this formula. So the easy way to spot a formula is to start by essentially plugging in n is 1 and then seeing what number we get and plug in n is 2 and so on, and then see if we can see a pattern emerge. So for n is 1, right? So s sub 1, meaning just if I plug in 1, this side is just a 1 over 1 plus 2, right, which is just a half. That's the sum. There's only the one term, so there's nothing to sum, it's just the one term. But my s sub 2 would be the sum of the first two terms, right, the 1 over 1 times 2 plus the 1 over 2 times 3, right? Well, that's a 1/2 plus a 1/6. Now, if I get a common denominator of 6, right, which would be the least common multiple here, this is 3/6, right, plus 1/6, so I get 4/6 or 2/3, right? Okay. Now, if I try s sub 3, and then, well, again, once we have a few of these, we'll get a pattern down. S sub 3 would be the 1 over 1 times 2 plus the 1 over 2 times 3 plus the 1 over 3 times 4, right? Well, we already know the sum of these first two, right? I could write them all out if I want, or I could just say, hey, wait a sec, I already know that that's a 2/3, right? So I already found that this piece, in the last step, I found that that was a 2/3, right, plus 1/12. Well, the common denominator is going to be 12, right? So this is 8/12 plus 1/12, so I get 9/12, which is the same if I cancel a 3 as 3 over 4. So I'm starting to see a pattern here. I'm starting to notice that when my n was 1, my sum ended up being 1 over 2, meaning n over n plus 1. And then when n was 2, my sum ended up being 2 over 3. Well, that holds up again, n over n plus 1. And when when I wanted s sub 3, I ended up with a 3, which was n, over 4, which is n plus 1. So let's try it one more time. Let's try it with s sub 4 and confirm that it actually works. So s sub 4 would be the 1 over the 1 times 2 plus the 1 over the 2 times 3 plus the 1 over the 3 times 4 plus a 1 over a 4 times 5. Well, we've already found the sum of the first three because we just did that right here. So that would be a 3/4 plus a 1/20. Well, the common denominator is 20, so I'm going to times by 5 over 5. And I'm going to get that this is 15/20 plus 1/20. So 16 over 20, which is a 4 over 5. And that holds up with the pattern that I had. So what I'm going to propose, the pattern I'm going to propose is that this sum, so in part A, my answer to part A, I'm going to propose that this thing sums to n over n plus 1. Right? That is the formula that I think, that's what I propose to be true. So now my part B, right, so that's my answer to A, that is my hypothesis for what this formula is. So part B then asks me, hey, use mathematical induction to show that that's true. Okay, so this is my P sub n statement, or you could use S sub n, that's fine. Okay, so number one, I have to show that this works for S sub 1 or P sub 1. So I'm going to show that S sub 1 is true. Well, that's if I plug in 1 times 1 over 1 times 2, right? And that should equal the other side, which is a 1 over 1 plus 1. Well, 1/2 does equal 1/2. Now, I'm not surprised by that because I wrote the formula based on the first four terms, and the first term definitely worked. The second thing I have to do is I have to assume that S sub k works, right? So I have to assume that S sub k is true, which means 1 over 1 times 2 plus 1 over 2 times 3 plus ... 1 over k times k plus 1 is going to equal a k over k plus 1. So that is a fact, right? That's an important part of induction. I'm going to assume that this piece of information is factual, right? So the reason that's relevant is because what I'm about to do now is in step 3, I need to show that P sub k plus 1 is true, right? Sorry, S sub k plus 1, because I was using S's, not P's this time. Okay, so S sub k plus 1 on the left-hand side would be a 1 over 1 times 2 plus a 1 over 2 times 3 plus ... up to the kth term, which would be a 1 over a k times a k plus 1, plus, and this is the important next term, 1 over, when I plug in k plus 1, I get k plus 1 times k plus 1 plus 1, which is k plus 2. On the other side, right, and I'm trying to show that these are equal, I would have instead of a k, I'm going to plug in a k plus 1, and instead of a k plus 1 on the bottom, I'm going to get a k plus 1 plus 1, which is a k plus 2. So this is what I'm trying to show. The first step in showing this, as we've seen before, is to use this fact that I have, right? Oh, sorry, that red marker is dead. Okay, here's the better red marker. This whole thing right here, except for the very last term, this is my S sub k. So I can replace this whole thing with a k over a k plus 1, right? Because that's a fact that we've assumed. And I'm adding to that a 1 over a k plus 1 times a k plus 2. Well, the cool thing about these is I'm really close to a common denominator already, right? And I'm trying to show that that's a k plus 1 over a k plus 2. Now, if you notice, both of these have a k plus 1 in their denominator already. So essentially, to get a common denominator, all I have to do is times this guy by a k plus 2 over k plus 2. So I'm going to give myself some space at the top because I definitely need some space for this, right? So if I simplify this statement now, I have a k times a k plus 2, so that'd be k squared plus 2k, plus a 1 on top of this common denominator of k plus 1 times k plus 2. And I'm trying to show, question mark, that that's equal to a k plus 1 over k plus 2. Well, if I factor the top, I get k plus 1 times k plus 1, or you could write it as a k plus 1 quantity squared. I don't care. Either way, what's going to end up happening is you'll realize that you have a k plus 1 that you can cancel from both the top and the bottom. So k plus 1 cancels, and sure enough, I end up with k plus 1 over k plus 2 equals the exact same statement on the right-hand side, QED. So the formula that we made for this sum was correct.